If you hook up two 6-volt lights to a 12-volt system, what you will do is burn the lights out. Period. There's no way around it. You can't get zero resistance on a circuit, else the circuit does not exist. The systems and the way that the circuits that you're trying to design will not work. It's impossible for them to work. Try plugging two 6-volt lights into a 12-volt battery. Yeah, see how long that lasts. He posted a comment on my most recent video. It said, "Care to make a bet?" Sure, Mr. Michael. I wouldn't mind making a bet with you. It defies math, physics, science, engineering, or any other field having to do with reality. So you make your video, you make your claim, and bet me whatever you want. However, there's a small problem here. I don't suspect you will.
Greetings. Some time ago I posted a video running an experiment on how to possibly cure the dilemma of directly running hydrogen oxide modules, otherwise known as HHO units, directly from a battery or your vehicle's charging system. And this is the main problem with skeptics and the whole thing in general. This experiment showed that you could run a hydrogen unit indirectly and get results, and you actually use less power than before. This technique is by no means perfected, and while theoretically you could hook it up directly to a vehicle's alternator, until the actual exact math is worked out, I would advise against it. However, the technique does not have to be refined. The math does not have to be perfect for it to run off of a motor scooter or a motorcycle with a headlamp that is constantly on while your bike is running. I later posted a circuit. I drew out a circuit explaining how this would work. Later I received, thanks to a certain desert dwelling individual, a crapload of messages stating that how this cannot work, especially one. I apologize that I blocked him, mostly because I couldn't discern him from all these other whack jobs that were giving me problems, thanks to this desert dwelling individual, pardon me. So we've had a few discussions back and forth after I unblocked him, and he still doesn't get it. So I guess it's for the benefit of the people that this has happened, because now I've actually gone back and bought some parts from Radio Shack to explain this circuit in greater detail and actually have a working model to explain this. So let's get to that. With a few simple things, we're going to make this demonstration. Here we have 3 sets of lights. First set, volt, 20 watts. Now I may have made a mistake here and gotten the wrong lights, but we'll make use of it for even a better example. On the front, I don't know if you can read that. It says for 4-cell flashlights. And on this package, 4-cell flashlights. Now this should be rated for 6 volts, but on the back says they are rated for just under 5 volts. And the other one says the same thing. So I was going to hook up 6-volt lights in series. That's what I thought these were, and I still think they are, because 4-cell flashlights, 4 1.5 batteries equals 6 volts. So if they are only good for under 5 volts, this will even prove my point even more, because it was stated that a 6-volt light would blow under a 12-volt power supply. So then a bulb rated for 4.75 volts should blow even faster than a 6-volt bulb. Here we have a 6-volt flashlight that comes with a 6-volt battery, and we have another 6-volt battery to go with it. Hooking these up in series will give us 12 volts. As you can see, battery number 1 works. We switched them out, and now you see battery number 2 works. Okay, so now we are ready for a little experiment. We have our batteries, we have some wire, we have some solder, we have our lights that are unopened. 4.75, 4.75, 12 volts. The camera's going to stay running, so that you know I didn't somehow sneak something into the video. Now if these are really rated for 5 volts, or just under 5 volts, then 3 of them should be fine for this circuit. Again, it was said that 6 volts couldn't be wired to a 12 volt supply, so 4 volts should blow even faster than 6 volt lights. Just putting some solder on these where we can attach the wire. Get some solder on some wire. Oh, come on. Now, one more. We now have 3 lights wired in series. We now have 3 lights wired in series with the wires attached. We will now take our 12-volt supply Now first we will touch it to the 6-volt light, or the 6-volt battery. You see we get some light. And now, if Chief Kyle 1 is correct, these bulbs should blow. At least one should blow, being that they're only rated for 4.75 volts. And we have a 12-volt supply here. Mathematically, these bulbs are rated for over 12 volts, seeing that they're hooked in series. And now we'll complete the circuit and they light perfectly. When you add bulbs, you add resistance. The first 6-volt battery should be enough to blow the first bulb. This is 6 volts. This is 4.75. According to these people who are well educated, this bulb should blow first because this bulb is only rated for 4.75 volts, and this is a 6-volt battery. But as you see, it doesn't. As we increase to 12 volts, they still do not blow. Why is that? Because every time you add a bulb, you are adding resistance. The more resistance, the more voltage it takes to push against that resistance. As you see, this circuit works fine. Now we'll take our 12-volt light and do another little test with it. See, our 4.75 bulbs are still lighting up perfectly. Now if we take our 12-volt, this is rated at 20 amps. If we can see this, the bulbs still light up good. This doesn't though, because we're pushing too much we're pushing against too much resistance. With only a slight dip in power, and it's not even really noticeable as I switch between the circuit that contains the 12-volt light and the circuit that does not have the 12-volt light. So little difference between the two that you really need a really fine amp meter to tell any difference. Why does it work so good? Because this bulb is rated for high amps. Therefore, it has little resistance in this circuit comparatively. This bulb has very little resistance. Therefore, the electrons barely know it's there, because to them this is just 2 electrons. This is just another circuit. There's so little resistance to it because of the high amperage draw that the electrons are not even phased by it, and the power is allowed to flow through the bulbs just fine. Now, to show you that this bulb is good, we're going to hook straight up to our 12 volt power supply. And you see it works quite well. It's also quite hot. We are now going to reconfigure these bulbs so that they do not run in series anymore. They will run parallel. And now, as you can see this, we have our bulbs wired differently. We have 4 of them now. The same bulbs, 4.75 volts. They are wired up in a parallel circuit. Before, these were wired up in series. Now they're wired up parallel, meaning we have positive going across all these terminals, and we have negative going across all these terminals. The amperage required to run those has increased, but the voltage to run them is the same, 4.75. If I were to hook up our 12 volt power supply, the bulbs would blow, all of them, almost instantaneously. If I hook them up to the 6 volts, they might handle it, but that's not what we're trying to prove here this time. What we have here is our 12 volt high watt bulb, and now we're going to take this and hook this up in series to our parallel lights. First, it's hooked up in series, and because of their added resistance of a second light, this light is hooked up in series to these lights. These lights are hooked up parallel because, as in the earlier demonstration, you saw that this light would not light to light these 3 bulbs, and this light acted as a perfect circuit. Now we're going to try to do it the other way around. We're going to try to draw enough amps through all these bulbs to get some reaction out of this bulb. Now, it won't be perfect. This bulb will not light up as bright as it did before, but it will be close. We will get some reaction out of it. There is a straight hookup to 12 volts, and to complete our circuit, let's see that again. Bulb gets hot, so bear with me. And now, just the one bulb. As you can see, by reducing the resistance by stacking these bulbs parallel, every time we add a bulb, we reduce the resistance. So we've reduced the resistance by a factor of 4, and it was able to power the 12 volt high amp light, which is exactly what I've proposed to do with my hydrogen units. The headlight bulb, represented by this, will be a little bit dimmer, but considering how much dimmer it is, it's only a little dimmer than that. And that is how I propose I am going to run my hydrogen units next summer.